Monday, 7th of January 2019, paper 1H solutions. Okay, first question is factorizing. So factorize fully, that means not just to take out a number but also take out a letter as well in this case. So 2 is common, p is common, 2p goes outside the bracket. What do you multiply 2p by to end up with 4p? You multiply it by 2. What do you multiply 2p by to end up with 6pq? Multiply by 3q. The next one, we can use whichever method you like. I like to draw the lines. So e squared minus 5e plus 3e take 15. The middle two combine to give you negative 2e. Multiply both sides by 5 to get rid of the divide by 5. Perform it's not quite a double swap because we're only going to eliminate the least y's. So when you have letters on both sides, you always deal with the lower of the two. So what I'll do is I'll take 2y from both sides, so you end up with 5y minus 2y is equal to, there's only 1 left on this side, so 3y is equal to 1, and that means y is equal to 1 over 3. I would not change this to a decimal. Okay, next question. So describe fully the single transformation that maps A onto B. So there are 3 marks for mentioning 3 points here. The first point is that this is a rotation. And next we're going to say how many degrees and in which direction, whether it's clockwise or anti-clockwise. So I'm just going to show you how to do this. Remember, in the examination you are entitled to tracing paper, so ask for it if you need it. Okay, what we're going to do is we're going to draw over triangle A, and we're going to take a guess at where we think the center point is. So you take a guess. Okay, now you can try somewhere around here. Let's just have a guess and say it's about there somewhere. Okay, what I'm also going to do is I'm going to draw an arrow on the page that points north, and this should tell me how many degrees it's rotated when I have rotated it. So let's take a look at this then. Okay, so rotate this. Oh wow, lucky first guess. So the arrow is now pointing east. It's gone from north to east, so it's rotated 90 degrees and it's gone clockwise. So we say that, rotation 90 degrees clockwise. Oops. And the center point is also correct. The center point is negative 2, 3. Okay, the next one says to translate triangle A by the vector 2, minus 5. 2 as the first number means 2 to the right, and then the negative 5 means 5 down, and make sure you rotate the correct triangle. It says triangle A, so choose a corner on triangle A. Just have a quick look at the scale to make sure every square is worth 1 in both directions, and it is. And we go 2 to the right, and then 5 down. 1, 2, 3, 4, 5. So this dot here represents the new top right hand corner of the shape, because I chose the top right hand corner. You can do it for every corner, or you can just draw the shape now. Label the new triangle C. Next question. Okay, so Enlarge scale factor half, center minus 4, 2. So they've marked the center point on for you. Choose a corner of the triangle and work out how you get from the cross to the dot. You go 4 right and 2 up. That's how you get from the cross to the dot. But because we're enlarging it with scale factor of half, we're going to half this, and instead of going 4 right and 2 up, we will go 2 right and 1 up. So I'll do that from the cross, 2 right and 1 up. Now what I'm going to do is draw the triangle, but remember to draw it half the size. So instead of 4 down, it goes 2 down. Instead of 2 across, it goes 1 across, and then so on. Next question. So Jenny spins the spinner 150 times. Right, let's have a look at this then. Now don't assume that brown and yellow have the same probability, because actually if you read this sentence, the probability of brown is 0.06 more than the probability of yellow. So if yellow is x, then brown is x plus 0.06. Now we know the table, probability tables, should add up to make 1. So let's just use my other calculator. What we'll do is we'll add up the numbers in the table. Okay, 0.15, add 0.26, add 0.33, add 0.06, and that gives us 0.8. So we have 0.8, plus there are 2 x's in the table, x at x is 2x, and all of that should equal 1. So if I rearrange this, I have 1 minus 0.8, which is 0.2, and that means x is 0.1. So that means if x is 0.1, yellow is 0.1, and brown is 0.1 plus 0.06, which is 0.16. I can now answer the question. Work out an estimate for the number of times it lands on yellow when she spins it 150 times. So when you're estimating with probability, you take the number of times and you multiply it by the probability that it lands on that colour. So the probability it lands on yellow is 0.1. 150 times 0.1 gives us 15. 15 is the final answer to the question. Next question, percentage increase. So you need the formula, which is difference over original times 100. The difference over original times 100. So the difference between the two numbers is the bigger one minus the smaller one. So 1236.50 minus 1126.50 over the original one. So originally it was 1126.50. You times this by 100, and you can type it into the calculator like that if you like. What you then need to do is write down the answer, which is, let's have a look. Okay, let's type this in. So 1236.50 minus 1126.5, 1126.5 times 100. Okay, 9.76475. Ran this to 3 significant figures. Remember, I always think it's a good idea to copy down the calculated display and then round it. So 9.76. Next question. The price of 1 ounce of gold on the 1st February 2016 was 1,126.50. That's fine. And it increased by 19% from the 1st of Feb to the 1st of July. Work out the price of 1 ounce of gold on the 1st of July. So you are increasing it. It hasn't been increased. You are increasing it. And if you want to increase it by 19%, there is a wonderful multiplier method that you can use. To increase a number by 19%, we use the multiplier like this, 1 plus 19 over 100. You type that into the calculator, that's 1.19. Multiplying a number by 1.19 increases it by 19%. So if we multiply by 1.19, let's do that, 126.50 times 1.19. We've got 1,340.535. Okay, and let's give your answer correct to the nearest dollar. So that's 1341. Next. Okay, so show that they're parallel. Okay. So where do we start? Well, if they're parallel, I mean, there are many ways to answer this question, but if they're parallel, then we have a Z here, and inside the arms of the Z, as in this one and this one, they should be the same angle. If the lines are parallel. So that's what we need to prove. That's one way of answering this question. What I also know is that angles on a straight line add up to 180 degrees. So this one here and this one here should add up to make 180 degrees because that's a straight line. And it tells me they're a straight line, so I can use that fact. Right, let's add them together first of all then. So we have 4x plus 15 plus 30x minus 5. And when you add them together, it should equal 180 degrees. So we have 34x plus 10 is 180 degrees. And that means if we take away 10 from both sides, 34x is 170. And if we divide 170 by 34, that means x is equal to 5. Now, the reason that we can do that is because angles on a straight line add up to 180 degrees. Okay. And now what I'm going to do is I've worked out that x is 5, so I'm going to work out the size of this angle here, work out the size of this angle, and hopefully they'll be the same. Because if these lines are parallel, they should be the same. So we have 30 times x minus 5. So 150 minus 5 is 145. The other one is 20x plus 45. So we have 20x plus 45. So we have 100 plus 45, 145. Okay. So they are the same. What does that mean about the angles? Alternate angles are equal, and hence the lines must be parallel. Okay, next question. So on your calculator you have a table mode for this. If you go to menu, table, and on the silver calculator this is mode table. It looks slightly different. So we enter the equation x squared minus 5x plus 6, and you start at 0 because the table starts at 0, end at 5, and it goes up in ones, and you copy down this table. 6, then 2, 0, 0, and then when it's 5, scroll down, it should be 6. Menu 1 to get it out of this mode. Okay, now plot the points. 0 goes to 6, 1 goes to 2, 2 goes to 0, 3 goes to 0, and 5 goes to 6. Now we're expecting a bowl-shaped graph, and you can see by looking at the points it looks like it's flat in between 2 and 3, But if you draw it so it's flat between 2 and 3, you won't get the marks. It's got to have its characteristic bowl shape. Okay, so like this. It must not be flat between 2 and 3. There you go. By drawing a suitable straight line on the grid, find estimates to the solution of this. Right. What you have to do is compare this with the previous part that you've drawn. Remember, we have just drawn the graph of y equals x squared minus 5x plus 6. Now that's quite similar to the left-hand side of this equation. The left-hand side of the equation has an x squared and it has a minus 5x, but it needs a plus 6 as well. So what we do is we add 6 to it, and now it's very useful because that's the equation of the graph that we've drawn. But you can't just add 6 to the left-hand side, you have to add it to the right-hand side as well to balance it. So when I fully balance this, we have x squared minus 5x plus 6 is equal to minus 7 and 6 is negative 1, so it's equal to x minus 1. So we have this graph drawn, y equals x squared minus 5x plus 6, but we haven't got this one drawn, but we are going to draw it. So let's draw y equals x minus 1. Now, of course, you can do this quite easily. However, if you want to use the table to help you, you can. So go to mode table again, and this time it's x minus 1. Go from 0 to 5. Plot the points. So 0 goes to negative 1, 1 goes to 0, 2 goes to 1, and so on. You can get these from the calculator or you can do it yourself. It's entirely up to you. Okay, then you plot the points and you draw the graph. And what you'll find is the line and the curve intersect at 2 points. The intersection points are the solutions to the equation. So what you need to do is draw a line down, and try to read these off as accurately as you can to 1 decimal place. And to 1 decimal place, we end up with something like around about 1.6. Right, x equals 1.6, comma, x equals 4.4. Okay, next question. Write this as an ordinary number. It's always worth trying this in the calculator. It doesn't always work. But if you try 7.18 times 10 to the power of 7, okay, so it's 718 with 5 zeros. Calculate the total volume of these 4 oceans. So what you need to do is add them all together. Now there is no point in changing these to ordinary numbers, it's a waste of your time. Just type it in like this, 1.88 times 10 to the power of 7 plus 3.10 times 10 to the power of 8 plus 2.64 times 10 to the power of 8 plus 7.18 times 10 to the power of 7. Okay, 6646 with 5 zeros. So we have it 6646 with 5 zeros. What we want to do is convert this into standard form. So standard form, we have to write all the non-zero digits, a decimal point after the first one, times 10 to the power of, let's have a look, 1, 2, 3, 4, 5, 6, 7, 8. There you go. Write this number in standard form, 9.88 times 10 to the power of, let's have a look, 1, 2, 3, 4, 5, 6. Okay, the area of this triangle is 12 centimeters squared. Work out the perimeter. So, how do you work out the area of a triangle? You base, well, at this stage of the paper, do base times perpendicular height divided by 2. The perpendicular height is this one. So we know that 5 times, let's call this x. Oh no, we can't call it x actually because the other sides are labelled x. We'll call it y. 5 times y divided by 2 is equal to 12. Now, there's one letter in this equation, so I can work it out. Times both sides by 2, so 5y is equal to 24, and that means y is equal to 24 divided by 5, which is 4.8. So this side is now 4.8. What I can do now is I can work out x quite easily, okay, by extracting a right-angled triangle from the diagram. So the height of the right-angled triangle is 4.8, the base is 2.5, and I can work out x using the theorem of Pythagoras. So a squared plus b squared equals c squared. C is always opposite the right angle. So you have a squared plus b squared is equal to c squared. Okay, and then we can write all of this in a square root to work out x. So it's the square root of 2.5 squared plus 4.8 squared, and that gives us 5.41. Okay, that's not very nice. So we're going to copy down some of the display. You mustn't round this number. That's x, but I want the perimeter of the shape. So it's going to be 5.412, all of the display, times by 2, 2x is there, plus the 5 at the bottom. So times by 2, then add 5, and that gives us 15.824. Okay, copy down some of the display, round it to 3 significant figures, 15.8. Okay, so now it's the first of the grade 6 questions. The last question was the last question on the foundation paper. So a cumulative frequency table means you keep a running total. So we have 3 here, another 16 to add on to the 3, which gives us 19. And just work your way down the table. So you have 43, 53, 58, and 60. On the following page, we're going to plot the points. So we always plot a cumulative frequency curve at the end points. So it's going to be 10 to 3 and so on. Now, observe the scale for a moment, just check. The vertical scale, each square is going up in 1, so that's fine. So 10 goes to 3, 20 goes to 19, 30, 43, 40 goes to 53, 50 goes to 58, and then 60 goes to 60. Now, it's up to you whether you join the first point to the last point, or if you join from 0, that's up to you. They accept either. So I will join from 0. And remember, when you draw this, it's supposed to be a freehand, smooth, elongated, S-shaped curve like this. Next one, use your graph to find an estimate of the interquartile range. So interquartile range, what we need to do is draw a line across at the upper quartile and the lower quartile. Now the data goes up to 60. We know that from the previous page. So that means the median will be at 30, which means the lower quartile, which is half of the halfway point, which is at 15. And then the upper quartile is 3/4, so 3 lots of 15 is 45. Okay, so these are where you draw lines across. In fact, you don't need to draw a line across at the median, but I like to mark it on anyway. So draw a line across at the lower quartile and at the upper quartile, and then draw a line down. These are your working outlines, quite important for the examiner to see where you're getting these numbers from. Okay, read the numbers off. So I get about 31 minus 19, so that's about, they're about 12-ish. Yeah. Okay, in the mark scheme, there's long as you have drawn correct lines, you'll be okay for this. Let's just have a look. In fact, in the mark scheme, it says accept answers 13 to 15. So I'm just slightly out, and that's probably because of the way that I've drawn it on the computer screen. It's not quite the same as drawing it on an actual script, but 13 to 15 is the allowable range. Okay, next question. Calculate the sides of angle BAC. BAC. So, this one here. We have two right-angled triangles overlapping each other. What I'm going to do is I'm going to use the bottom right-angled triangle, and I'm going to work out this side here, CD. CD will eventually allow me to work out the length of BD, which will allow me to work out the size of all of this angle here. So that's the idea in this question. It's all to do with right-angled triangles, so it's got to be basic SOHCAHTOA. So let's consider the smaller triangle at the bottom, triangle A to C to D. Okay, this angle's 20. We have 13 centimeters at the bottom, and I'm going to work out this side CD using trigonometry. So this is the opposite. Okay, it's opposite the marked angle, and 13 is between the right angle and the angle, which makes it the adjacent. So this is TOA. So I can draw my little TOA triangle, so it's TOA, and then start to fill it in. So we have tan 20, O at the top is x, and A is 13. And if I want to work out x, I can cover x, and I'll do tan 20 times 13. So tan 20 times by 13, and that gives me 4.73. So let's write that down. 4.73. Can't round this because it's not the final answer, so I'm just going to copy down the display for now. Okay. Now let's consider the slightly larger triangle, which is ABD. So we have A to B to D. Okay. This is 13 again. And BD now I can work out because it's going to be 4.73 add 8. So this is going to be 12.73. Okay, remember to use the entire display. Now I can't work out the purple bit, which is angle BAC, but I can work out this red one that I've marked on, which is BAD, which is this one here. Okay, so let's label the sides again. So this is O, so opposite the angle, and this is A, between the right angle and the angle, so again it's tan. So if I fill in the triangle, you have tan of the angle, okay, let's call this x, so tan x is equal to opposite over adjacent okay, and then when we cover the tan x up, we're going to do it tan x is equal to 12.73 etc over 13, and the inverse operation of tan is inverse tan, so if we inverse tan this fraction, we will work out the angle. So we've got 12.73, so we're going to do shift tan fraction ands over 13, and this gives us an angle there of 44.4. So let's write that down. Remember, this is still not the final answer, so I'm just going to copy down the display. 44.40241 etc. And that's all of this angle here, but we just want angle BAC. So if we take away 20 from 44.4, we end up with the BAC. So minus 20 from that, we end up with 24.40241, and then when you round it to one decimal place, it's 24.4. Next question. So algebraic fractions. Okay, we need a common denominator here when we're adding or subtracting. So we can make both of these denominators 6x. Okay, so like 6x. Yep. What do you do to get from 3 to 6x? You times it by 2x. So you times the top by 2x. 5 times 2x is 10x. What do you do to get from 2x to 6x? You times it by 3. So you're going to times the top by 3. So write your minus, and then when you times the top by 3, you must write it in brackets like this. Okay? Don't actually times it by 3. Just write 3 brackets. Do the expanding on the next line. Okay? Remember, this negative 3 is multiplying the bracket, so when you expand it like this, you ignore the 10x. So you have 10x minus 3x minus 6 over 6x. Every line must contain a fraction. So 10x minus 3x is 7x, and then you've got your minus 6 over 6x. And this is the final answer to the question. Okay, find dy by dx. So differentiate this. 3 times 1/3 is 1. And then you reduce the power by 1. So you get x squared. You can write 1x squared if you want to. You don't have to. 1 times negative 9 is negative 9, and then it becomes x to the power 0. But we don't write x to the power 0 because x to the power 0 is 1. And the number 1 just disappears. Bye-bye. So it's x squared minus 9. Find the range of values of x for which the curve C has a negative gradient. So the gradient is represented by dy by dx. Yep, that's what gradient is, dy by dx. It's a gradient of a curve. They're asking, when is the gradient negative? So what you can do is you can set dy by dx and make it negative, which means it's less than 0. So what we're trying to do is solve this inequality. Solve x squared minus 9 is less than 0. So how do we do that? Well, what we can do is we can draw a sketch of the graph x squared minus 9. Now an x squared graph is a bowl-shaped graph like this. Yep. However, when it's shifted down by 9, it looks like this. So it's x squared minus 9 looks like this. Okay. It crosses the y-axis at negative 9 and it has a bowl shape. Now what we can do is we can work out the roots of this quadratic, and we can do that by solving it. So let's just pretend for a moment that it's not an inequality and it's in fact an equation. X squared minus 9 equals 0. So then we have x squared equals 9. So x is equal to the square root of 9, which is plus or minus 3. So these are the roots you see, plus or minus 3. Now what we're trying to do here, we're solving a quadratic inequality, is we're trying to work out when is the graph less than 0. When is it less than 0? Less than 0 means when is it below the x-axis. So let's just draw some lines here. In this kind of patch in the middle here, yep, the graph is below the x-axis, beneath the x-axis. Yep. And you can see that quite clearly. After this point 3, I've written negative 3 there, there should be positive 3. The graph is positive in this section because it's above the x-axis, and over here it's above the x-axis, so that means it's positive. I should say positive 3. So we're looking for the part where it's negative, where it dips below the x-axis, and it dips below between minus 3 and 3. So that's the answer to the question. Find the range of values for where it's negative. So it's negative between minus 3 and 3. You have to be careful here not to write less than or equal to, because it's only where it's negative. At 3 and minus 3, it's not negative, it's 0. 0 is not negative. Okay, next. So we're going to complete the Venn diagram here. Okay, let's try to fill in from the middle bit first, and I'll mark it off as we go along. 15 people study all 3, so 15 go in the middle here. 21 study geography and history. That's this overlap here. That's supposed to be 21, but we already have 15 in this bit, so this has to be 6. 16 study geography and religious studies, so this section here should be 16, that means this is 1. 30 study geography, so if we add the numbers up in the geography circle so far, we have 22, that means this is 8. 18 study only religious studies, so only religious studies will be in this bit here. And 37 study religious studies, so if we add these numbers in the circle so far, we have 34, so we have another 3, it's got to be 37 in there altogether. Okay, and if you read the question at the beginning, it says all the students must study at least 1. That means there are 0 students outside of the circles, and if you add all of the numbers up inside the circles and then subtract it from 65, because there's supposed to be 65 altogether, you'll see that there's 14 remaining, so they must go in this section over here. A student in Year 11 who studies both history and religious studies is chosen at random. So they study both religious studies and history, and that is, let's have a look, that's in this section here, history and religious studies. Okay, so we already know that this fraction has to be out of 18, because that's the only section of the Venn diagram you're looking at. Now in that orange section, how many of the students do not study geography? Well, 15 of them do study geography within the orange part, so 3 do not. So the answer is 3 over 18. And it's entirely up to you with probability whether you cancel it down or not. They're not fussed, but this is the answer to the question. Next question, t is directly proportional to the cube of r. So t is directly proportional to the cube of r. T equals kr cubed. 21. Find out k. 21.76 is equal to k times 4 cubed. You want to know what k is? Divide 21.76 by 4 cubed, and that will work out k. K turns out to be 0.34. Okay, so you got your first mark, this is the second mark. The third mark is for going back to the first line, but replacing the k with the number that you have just found out, which is 0.34. Work out the value of t when r is 6. So we have t equals 0.34 times 6 cubed. 0.34 times 6 cubed. Okay, and you do that, you get 73.44. Okay, next. So the total surface area of a solid hemisphere is equal to the curved surface area of a cylinder. Right, so okay, let's have a go at this then. Now you will need to look at your formula sheet for this. Okay, but I'm just going to draw. I was hoping to look for a diagram, but I'll draw one myself. So a hemisphere, half a sphere, and we have a cylinder as well. Okay, so the total surface area of a solid hemisphere. Now this word solid is very important because we have the dome part to consider plus the circle at the bottom. Now the formula for the surface area of a sphere is 4 pi r squared, but this is a hemisphere, so we're going to half that. That's going to give us 2 pi r squared. But let's not forget that the bottom of the hemisphere is a circle, which is pi r squared. So we have 2 pi r squared from the dome bit, and then, or the curved bit, and then pi r squared from the bottom bit, the circle. So that gives us 3 pi r squared. The formula for the curved surface area of a cylinder is 2 pi r h, and this is on the formula sheet. Yep. Now, what they tell us is that the radius of the hemisphere is r, but the radius of the cylinder is twice the radius of the hemisphere. That means it's 2r. But these areas are equal to each other. So what we're going to do is try to substitute all that in. So we have 3 pi r squared is equal to 2 pi, and r is not r in the cylinder, it's 2r times h. Right, what can we do here? Well, we can simplify a little bit. So let's have a go. Simplify. So we can cancel a pi with a pi, that's for sure. You have 3r squared is equal to 2 times 2 is 4, so 4rh. We can cancel an r from both sides, so we're left with 3r equals 4h, and in a moment we can rearrange this, either to make r the subject or to make h the subject. I don't really know just yet. So let's have a look. The volume of the hemisphere to the volume of the cylinder is in the form 1 to m. So the volume of a hemisphere, remember a sphere's volume is 4/3 pi r cubed. Okay, if you half this because it's a hemisphere, you get 2/3 pi r cubed. The volume of a cylinder is pi r squared h. So we have the volume of the hemisphere to the volume of the cylinder, but don't forget that in the volume of the cylinder, r is not r, r is 2r, so it's pi r squared h. Okay, but remember r is 2r, so it's 2r all squared, and that's in the form 1 to m. Right, let's simplify a little bit on the left hand side here. We've got 2/3 pi r cubed. I'm going to try and sort this one out. So 2r all squared gives us, let's write it up here, we have pi times 4r squared times h. Now the problem with this line is we have a mixture of r's and h's. So now I've realised that I want to make h the subject in this line above. Then I can replace it with r. So if I make h the subject, we have 3/4r is equal to h. So now I can change the h in this to 3/4r. So let's do that. We've got pi times 4r squared times h, remember, which is 3/4r. Now what happens here when you simplify all of this? Well, the 4 here cancels with the divide by 4, and in fact you're left with pi, actually let's write the 3 here, you get 3 pi r cubed, and that's in the form 1 to m. Right, so how do we deal with this? Well, what we can do now is we can change this slightly. There's a rule that says when you have, let's write it down here, when you have a to b and it's in the form c to d, then this is true. A over b is equal to c over d. But it's also true to say that b over a is equal to d over c. So this is true from this ratio, if you have a ratio equal to a ratio. Now I'm trying to work out what m is. So it's nicer to use this version, because if I use this version, I will write down m over 1. And we all know m over 1 is m. So we have 3 pi r cubed over 2/3 pi r cubed is equal to m over 1, and m over 1 is m. R cubed cancels with r cubed, pi cancels with pi, and all we need to do now is 3 divided by 2/3. Type it in the calculator, or you can work it out yourself, and you end up with 9/2, which is 4.5. 4.5 is equal to m. Okay, what we need to do with this question is multiply the top and bottom of this fraction by the conjugate of the denominator. The conjugate of the denominator is the same denominator but with the opposite sign. So we're going to multiply by a plus 4 root 4b over a plus root 4b. And we can expand the top using double brackets like this, and we can expand the bottom in the same way. Let's have a go at the top. So a times a is a squared. A times root 4b is a root 4b. In the middle, a times root 4b is a root 4b. And finally, we have a positive and a positive, which makes positive when we multiply. And when you times a surd by itself, you just end up with what's inside it. So you just end up with 4b. Okay. In the denominator, let's have a look at what happens. So we have a times a is a squared. We have a times root 4b, which is a root 4b. And then you have minus, we have a times minus root 4b, which makes minus a root 4b. And plus and a minus make a minus. When you multiply a surd by itself, you just get what's inside it, so you get minus 4b. These two are the same, so they cancel. And on the top, you can simplify slightly. You have a root 4b plus a root 4b. So you have two of these. You have two of the same thing. So you have 2a root 4b. That's what you get when you simplify these two terms here. Now, what else can you do? Well, when you have a surd like this, you can work out the square root of each part of the product inside the square root. So like this, 2a, and that's root 4 multiplied by root b. That's a law of surds. And the square root of 4 is 2. So we have 2a and then times 2 root b. So actually that simplifies to 4a root b. So what we can do now is we can write the final answer as a squared plus 4a root b plus 4b over a squared minus 4b. And that's the final answer to the question. Right, this one, find the value of m. Okay, so first of all, what effect does the square root have? The square root means to the power of a half. So we can rewrite this as y over x to the power of a half. But this is all raised to the power of negative 5. Now, what effect does the negative have on a fraction? The negative means it's the reciprocal, which means you flip. So what we can do is we can flip the fraction. Okay, we'll write it as x over y to the power of a half, which is all to the power of 5. Okay. Now, when you have a bracket to a power, you times the powers. So this is x over y, and then if you times 5 by a half, you get 5 over 2. When you have a bracket like this to the power 5 over 2, you apply the power of 5 over 2 to both of the parts of the fraction, so to the top and to the bottom, which is why it says x to the power m and y to the power of m. They're both to the power of 5 over 2, so m is 5 over 2. So this question is to do with the sine rule and cosine rule. And we know that because this is a non-right angled triangle and it's towards the end of the paper. You have to ask yourself this question to decide whether it's the sine rule or cosine rule that you use. Do you know a side and its opposite angle? If the answer is yes, you're going to use the sine rule. If the answer is no, use the cosine rule. So do we know a side and its opposite angle? Well, no. So that means we're going to use the cosine rule to work this out. Now, how do we use the cosine rule? Well, we've got two versions of the cosine rule. We have the one on the formula sheet, and there is a rearranged version of the cosine rule to work out an angle. Now, if you're going to use the cosine rule to work out an angle, you must have the side which is opposite. You need the two sides that sandwich the angle, and then the opposite side is the one that you're trying to work out. So, in this case, we can use the cosine rule to work out this side AC. Actually, I shouldn't call this X, because they've called the angle X. I'll call it Y. So we can use the cosine rule to work out this side here. Yep, we have two sides that sandwich this angle, and we can work out the length of AC, which I've labelled Y. What we can't do is work out angle X using the cosine rule, because in the cosine rule, B and C are the sides that sandwich the angle, but we don't have two sides either side of this angle, so we can't work out the angle using the cosine rule. The only thing that we can work out is the length of AC, which I have labelled Y. Okay, so let's have a go then. The cosine rule from the formula sheet is a squared equals b squared plus c squared minus 2bc cos of a. I don't bother with the labelling of the triangle using the letters that the exam board state. What I do is label the two sides either side of the angle B and C. Doesn't matter which way around, C and B, B and C. But as long as you label the two sides either side of the angle B and C, and then the other one is A. So, according to my diagram, it's y squared equals 5.3 squared plus 4.1 squared minus 2 times 5.3 times 4.1 times cos of 110. Okay, that's equal to y squared. So y is equal to the square root of this. And you can type this in one long square root. Okay, and you end up with something like 7.73073, etc. Okay, let's type this in anyway, because I'm going to have to use the display later on, the ANS button. It's got 5.3 squared plus 4.1 squared minus 2 times 5.3 times 4.1 times cos 110. Okay, this is y squared, so square root it. Right, I'll leave this on the screen as I'll probably need it in a moment. So I've worked out that this side is 7.7 approx. Remember, I can write 7.7 on the diagram, but I'm going to use the full calculated display when I work out any other angles or sides. So, go back to the question now. Ask yourself the question again. Do you know a side and its opposite angle? And the answer this time is yes, because you know 110 degrees is opposite to side 7.7. So now we can use the sine rule to work out angle X. And remember, the sine rule that's on the formula sheet is very useful for working out a side. If you want to use the sine rule to work out an angle, you write down the same sine rule but upside down. So sine A over lowercase a equals sine B over lowercase b, etc. So we're going to do that. You pick an angle, so like X, we write sine X over the side which is opposite to that, which is 5.3. and that's equal to sine 110 degrees over the side which is opposite to that, which is 7.7. Okay, full calculated display, of course. A little bit of rearranging now. What we'll do is we'll times both sides by 5.3. Okay, and this is equal to sine x. Well, let's have a go at typing this in the calculator. So we have sine 110 over ans, previous display, times 5.3. Okay, so this is an unusually small angle, and that's because it's not an angle. It's sine of the angle. Sine of the angle is 0.644. Okay, 0.644. That's sine x, and we would like x. So the how do you undo sine? It's inverse sine. So shift sine of your answer, and you end up with 40.107, which you then round to three significant figures. In this case, which is 40.1. Okay, next question. On the grid above, sketch the graph of a half y equals f of a half x. So I'm just going to put some dots, really nice points on this parabola, which are on corners of squares, and I'm going to adjust these dots accordingly. So what does f of half x mean? F of a half x. Well, let's take a look. So this coordinate is -2, 5. Now the x coordinate is currently equal to -2 and the y coordinate is equal to 5. And what we're trying to do is work out what happens to this coordinate under the transformation f of a half x. Now as you can see, the original curve is y equals f of x. But what has happened? Well, the x has changed to half x. So think about it like that. Start like this. Your x coordinate at the moment for this particular point is -2. And under the transformation, the x has changed from x to a half x. So that's what you do. In your coordinate, you replace the x with half of x. So now half of x is actually equal to -2. If half of x is equal to -2, what is a full x equal to? Well, you double, don't you? If you know half of x is -2, then x is equal to -4. So that means, in effect, what we are doing is actually doubling the x coordinates. So for all of these points, the y coordinate stays the same, as you can see. It's just the x that changes and it doubles. So we change that over here. This is -1, so it becomes -2. This is 0, so when it's 0, obviously it's anchored because 0 times by anything is 0. So this next one is 1, so it changes to 2. The next one is 2, so it changes to 4. Next one is 3, so it changes to 6. And this one is 4, so it changes to 8. Okay, nice points. Join them up. There you go. Okay, so the next question, y equals f of x plus k. Let's take a look at the point that's furthest on the right hand side. This is 1, 5, and on the previous graph, it was 4, 5. Okay, so 4, 5. So 4, 5 transforms to 1, 5. Now let's take a look at this, y equals f of x plus k, and see what happens. If you have a situation like this, where you start off with y equals f of x, and you change this to, I don't know, let's say f of x plus 3. Right. Let's have a look at what happens to get from here to here. Well, originally, your x coordinate is equal to 4. And what do you do in under your transformation? You change the x to x plus 3, so you end up with x plus 3 is equal to 4. And then, when you rearrange it to work out your x, if you take 3 from both sides, you end up with 1. So it starts off at 4, but it ends up at 1. Now, what's actually happened there then? Well, it moves or translates 3 to the left. So when you see x plus 3 in the brackets, it actually shifts the graph, translates the graph 3 to the left, which is what has happened here. So what it means is k must be 3. Okay, next question. Question 19. So we have some information about a parabola, x squared plus 6x. Write down the range of the inverse function. Now there is a wonderful fact here that you need to know, that the domain of g of x is equal to the range of the inverse function, and vice versa applies as well. So the domain of the inverse is equal to the range of g of x. Now if you just think about why this is true, what does domain mean? Domain means the x values for which the curve is valid. Okay, so in this question they tell you that the curve is only valid when x is greater than or equal to -3. So if you're drawing a sketch of the graph, you shouldn't draw the graph before -3 on the x-axis. But you see, as part of the inverse function, one of your lines of working is to swap the x with y. Well, what does that do? Well, if you think about it, you're interchanging all your x and y coordinates, so the graph is actually a reflection in the line y equals x. Now, if in the original curve the x values are only valid for numbers greater than or equal to -3, when you end up swapping the x's and y's around, then the y values of the inverse function will also be only valid for values greater than or equal to -3. That's what range means. Range means y values, which y values are valid on the inverse function. It's the same as the x values on the original function. So the answer you can write like this. Remember, there's no y here. It's just, instead of a y-axis, it's the g minus 1 of x-axis. So the answer looks like this. Now you can write range is greater than or equal to -3 if you want to. You shouldn't really write y. They may accept it. Okay, so the inverse function. Express the inverse function in this form. Now, if you try to do this in the usual way, you're going to encounter some problems. An inverse function of a quadratic like this, where it's where you have an x squared and some x's, you have to know the little trick, which is to first of all complete the square. That makes working out the inverse function much nicer. So what we're going to do is just rewrite g of x first of all. You have to know this. This comes with a bit of practice. So if we complete the square, completing the square makes it something like this. So it's x plus half of the coefficient of x, which is 3, all squared, and then you subtract the number in the bracket squared. So this is the completed square for x squared plus 6x, and now we can start with the inverse function. So y equals x plus 3 all squared minus 9. Interchange your x and y, so x is equal to y plus 3 squared minus 9. And now try to rearrange it so y is the subject. So add 9 to both sides. Try not to expand the bracket, and it's quite tempting. But instead, take the square root to get rid of the square. So it's x plus 9 rooted is equal to y plus 3. And then the square root of x plus 9 minus 3 is equal to y. So we can write this on the answer line. Just make sure that the negative 3 is not inside the square root. Okay, and you can avoid writing it so it's inside the square root by writing the negative 3 first, like this. That's the answer. Okay, next one. So a bowl contains n pieces of fruit. 4 are oranges and the rest are apples. Right, we're going to draw a little tree diagram to see what's going on. Okay, we have oranges and apples. 2 pieces of fruit are going to be selected, so that's the first piece, and then we have the second piece over here. Okay, so let's take a look at this then. We have n pieces of fruit. We've got 4 oranges, so 4 out of n, and the rest are apples, so this is still out of n. But the easiest way to think about this is, imagine there were 10 oranges. 4/10 would be the fraction for oranges if there were 10 pieces of fruit. So if there were 10 pieces of fruit, 4/10 would represent the number of oranges. What would you write down for the apples? Well, you would write down 6/10. Well, where do you get 6 from? You get 6 from 10 take away 4. So in a similar way, we do n take away 4. Okay, now it doesn't say anything about the fruit being replaced. So what I'm going to do now is work out all of these branches. I may not need all of them, but just do them all anyway. They're all going to be out of n minus 1 because you have, at this stage, you have selected 1 piece of fruit. So there's going to be 1 less in the bowl. So let's deal with oranges first. Originally there were 4 oranges, and you take an orange, so now there's 3. But you haven't taken any apples, so there's still n minus 4 apples. Okay, go back to the beginning. This time you take an apple. So there's still the same number of oranges, 4, but there's 1 less apple. So 1 less apple means originally there was n minus 4, and now you take 1 out, so then it's got to be n minus 5. Now let's have a look at this sentence, try to understand what's going on. The probability that the bowl will then contain n minus 6 apples is 1/3. Right, so after you have taken your 2 pieces of fruit, that's this stage here, okay? So you've taken 1 piece when you get to this, over to this stage here. When you get to this dotted line, you have now taken 2 pieces of fruit, okay? So what I'm going to do is I'm going to just write down how many apples are in the bag after each different case, and there's 4 cases here. So here, you've taken 2 oranges. If you've taken 2 oranges, how many apples are in the bag? Well, originally there was n minus 4, so there's still n minus 4. Okay. Next one, you've taken 1 orange and 1 apple, so there's 1 less apple in the bag. So originally there was n minus 4, but there's 1 less, so now there's n minus 5. This one, you've taken 1 apple followed by 1 orange, so only 1 apple less. So originally there was n minus 4, it's 1 less, so now it's n minus 5. And in this case you've taken 2 apples, so we're going to subtract 2 from n minus 4, and that gives us n minus 6. So what the question is saying is, the probability that the bowl will then contain n minus 6 apples is the third. Well, I've just shown you with a bit of detail that actually they're talking about this branch only. This is the only one which will result in n minus 6. And we know that the probability of it is a third. So how do you work out apple, apple? What do you do when you move along the branches of a tree diagram? You times. So it's n minus 4 times by n minus 5 over n minus 1, and that should equal a third, because they tell us it's a third. Right, algebraic fractions then. How do you times fractions? Well, what we'll do is we'll write both of these in brackets. We're going to use our expanding method on the top. I like to draw the little lines, and a single bracket on the bottom, and we'll try to combine that. So, on the top, we end up with n squared, then there's a minus 5n, and a minus 4n, which will give negative 9n. I've got minus 5 times minus 4, which is positive 20. In the denominator we have n squared, remember we're doing this, and then minus n equals to a third. Now, when you have a fraction equals to a fraction, we can use that x factor method where we multiply diagonally. So we're going to times the entire numerator here by 3, and we're going to times 1 by n squared minus 1. And when we do that, we end up with 3n squared minus 27n plus 60 is equal to n squared minus n. This is a quadratic. It should equal 0. So if we do a bit of rearranging, we end up with 2n squared minus 27n, minus 26n plus 60 equals 0. Okay, just got to solve this now. Various ways you can solve this. You can use the quadratic formula. You may have a sharp mathematical eye and spot that all of these terms divide by 2, which is what I'm going to do. This is a lot easier to factorise. Okay, so I'm going to factorise it. It does factorise, or you can use the formula. So the way I factorise this is using the AM method, and what that means is there are two numbers that add to give negative 13, but multiply to give positive 30. So numbers that times to make 30, you've got 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Okay, I want to end up with negative 13 when I add them, so I can use 10 and 3 if I make them both negative. And that means n is 3, or n is 10 when you solve. Okay, you set the bracket equal to 0, and you rearrange it to work out n. So n is either 3 or it's 10. Now, one of these answers is usually negative, and then you disregard the negative. Here they're both positive, but n cannot be 3. There cannot be 3 pieces of fruit in the bowl if there are 4 oranges, because there's already more oranges than there are pieces of fruit. So it has to be 10. Next question. Right, this is to do with arithmetic sequences. Okay. So this word arithmetic, in terms of sequences, what it means is the sequence has a common difference. So you will always add 2 to get to the next term, or always add 3, or take away 4, something like that. So whatever I add to get from the first to the second, I add the same thing to get from the second to the third. And that's what I'm going to do. I'm going to try and figure this out. What do I add on to get from the first term to the second term? Well, I can tell by looking at this that to get from 2x to 8x, it's add 6x. To get from 23 to 2, you take away 21. So that's what I do to get from the first term to the second term. Okay, now I just did this by looking at it, right? You can adopt a more formal approach and do the second term minus the first one. But if you do that, when you subtract the first term, you have to subtract both bits, so it's minus brackets 2x plus 23, So then it becomes minus 2x minus 23, and this tidies up to give 6x minus 21. Now, how do I get from the second term to the third term? Okay, what do you do there? To get from 8x to 20x, you add 12x. To get from 2 to negative 52, what do? You take away 54. Okay. Now, the bit in black is the difference. The bit in red is the difference as well. But the difference is common, so that means these two should be equal. And that means I should be able to work out x. So a little bit of rearranging. I'll do a double swap here. What I'm going to do is I'm going to shift the least x's to the side with the most. So that's going to go to the right. And therefore the numbers are going to go to the left hand side. So a little bit of swapping around. So you're going to do it 12x minus 6x. You have negative 21 plus 54. Now, negative 21 plus 54. Let's have a go. Negative 21 plus 54. Oh my god. Negative 21 plus 54. That's 33 is equal to 6x. And then if I divide both sides by 6, 33 divided by 6 is 5.5. So now I know x is 5.5. Okay, and the question says prove that the common difference is 12. So what do I need to do now? Well, I know that the common difference here in black is 6x minus 21. If I do 6 times 5.5 minus 21, that gives you 12. Type that into the calculator, it gives you 12. The other one is 12 times 5.5 minus 54, which is also the common difference. If you type that into the calculator, it's also 12. So therefore, you have now proved that it's 12. Next. Oh, is that the last one? Okay, thank you very much.